All right, I want to talk about amortization, and that's a fancy word that has to do with paying off a debt. In financial math, we're either investing or we're borrowing. So amortization deals with borrowing or paying off a debt. All right, let's get to it. First, I'm going to compare amortization with compound interest. So let's say we borrow $1,000 and we want to pay it off in 4 years. But let's say we have to pay interest at 5% compounded monthly. All right, so we're borrowing $1,000 and we want to pay it off. So we're borrowing. This is an amortization question. Maybe. This may be an amortization question, or it may be a compound interest question. Well, what's the difference between compound interest and amortization? They both have to do with borrowing. In compound interest, we make one payment in 4 years, right? We're borrowing $1,000 for 4 years. So compound interest would be you pay the interest and the $1,000 in 4 years, whatever that amounts to. Just remember, you make one payment with compound interest. One single payment at the end of 4 years. But what about amortization? The key with amortization is that we are making periodic payments, right? So you see the difference? We're either making one payment or periodic payments. All right, so now you know the difference between amortization and compound interest. Now, one thing to note is that we will assume that the compounding period is the same as the payment period. So this thing mentioned compounded monthly. So we're going to assume with amortization that you're paying monthly if the compounding is monthly. All right, so let's take a look. Next, we want to understand the question of amortization. So here it is. How much is currently in an account that makes 2% yearly interest compounded monthly if we are withdrawing $600 a month and empty the account after 4 years? Round your answer to 2 decimal places. All right, so let me point something out. We're looking for how much we have currently. It says, how much do you have currently in an account? We got the interest rate, it's 2%. We got the compounding period, it's monthly. It says even that we're withdrawing $600 a month. But realize that we want to know what we have currently. We want to know what amount of money do we have right now if we're going to draw $600 from it every month. We're drawing $600 every month. We're paying 2% interest because we still owe money. But the question is, how much money did you sort of borrow, right? It's kind of hard to realize that this question deals with borrowing some money. It doesn't say how much did you borrow anywhere in the question. All right, so the formulas for amortization are right here. P stands for the amount borrowed. R stands for the periodic payment, which in this case would be 600. And I and N, we've seen those before. I is the periodic interest rate. N is the number of periods. One thing that I notice is that the exponent is negative. In annuity formulas, the exponent is positive, whereas in amortization, the exponent is negative. Okay, lastly, we are gonna solve the question dealing with amortization. All right, so how do we solve this? Well, which formula should we use? What are we trying to find? Are we trying to find P or are we trying to find R? Most questions dealing with amortization, you're either trying to find P, the amount borrowed, right? Amount borrowed, or R, which is the periodic payment amount. Well, it said how much is currently in an account. Like right now, that's the amount borrowed. Plus this $600 right here, what does it say about that? It says we are withdrawing $600 a month. So if it's happening every month, that means it's periodic. That means it's R, the periodic payment, or withdrawal in this case. Okay, so it looks like we're going to use that formula. We're going to try to find P. First, let's be clear on I and N. I equals to the periodic interest rate. So that equals to the yearly interest rate divided by the compounding period. The yearly interest rate is 0.02 and it's compounding monthly, so that's 12, so that's I. Now N equals to M times T, and M is 12 because it's monthly. How many years is it? 4, so that's 48. Okay, so we have everything we need. P equals to 600 times 1 minus 1 plus 0.02 over 12 raised to the negative 48 divided by I, which is 0.02 divided by 12. And if we plug that in, that's the answer. So let me pull up a calculator. You need a really good calculator for this. So 600 parentheses fraction 1 minus parentheses 1 plus 0.02. Actually, let me pull a fraction here. 0.02 divided by 12. Close that parentheses. Raise it to negative 48. Divided by 0.02 parentheses 48. Actually 12. And that should be good. 600, yep. So there we have it. $27,000. 655.98. So as you can tell, this formula is very difficult to plug in, but with my calculator, it's easy to plug in because I have fraction notation, exponent notation. I have all of these buttons which allow me to clearly plug this in. So the calculator that you use is very important. Make sure you have a good one. All right, hope that helps.